Hello students, welcome to classroom. In today's video, we will be learning about how to solve numericals on myopia and hypermetropia. In the syllabus, there are one or two questions which you have to be prepared and which you have to solve. So it's part of your syllabus. So it is important for each and every one of you to know this. Now, these are not very difficult. Okay, all you need is a strong concept of the previous chapter, which is chapter 9, light, reflection and refraction. There you have already studied lens formula and then power. So you need these two only. And then to solve this question, it's easy. You just have to know how to apply, okay, how to reason appropriately, which I will teach you in this video. So it's going to be a very interesting video. So let's continue and let's start with the video now. So myopia and hypermetropia. Let's revisit what they are first. So myopia is short-sightedness in which a person can see near but has difficulty seeing far. Hypermetropia, on the other hand, is long-sightedness in which a person can see far but has problem seeing near. So now there are numericals on myopia. So how do we solve numericals on myopia and hypermetropia? Now it's easy. The first thing that you have to do is, okay, like let's differentiate myopia and hypermetropia separately. So let me write here myopia. First of all, I'll teach you the concept. Okay, I'll teach you the concept. So right now I'll be teaching you the concept. So the concept, let me give out the concept, and once we are done with the concept, solving the numerical is going to be super easy. So myopia and then hypermetropia. Now in order to the questions on myopia and hypermetropia, if we go through the questions on myopia and hypermetropia, mostly they are asking to find power. Okay, they want us to find power. Now we know the formula of power. Power is reciprocal of focal length. So we need focus. In order to find power, we need focus. Okay, now from where do we get focus? In order to get focus, we have to use this formula: 1 by v minus 1 by u is equal to 1 by f. Now this is lens formula. Yes, no, this is lens formula. This is lens formula. So we know this lens formula. So to find the focus, we need lens formula. In order to find focus, we need v and u. Is it not? See, we need v and u to find focus, is it not? So we need v and u. So numericals with myopia and hypermetropia, we have to find only these two. You need to find v and u. You need to find u and v. These two only. So if we can have our u and v, then finding the focus will be easy because we will be using lens formula. Okay, so let's try to find out, okay, how do we sort out our u and v in both myopia and hypermetropia. Now see, it will be like this. Let's start with myopia first. So let us find out like what will be u. Now see, we have to find out u for both myopia and hypermetropia. These two, okay, will not be given in the question. If they give you in the question, well and easy, but okay, mostly they don't give. Okay, so this has to be derived, okay, by us. So let me teach you how to derive u in both myopia and hypermetropia. Now let's say we are doing a question on myopia. Now myopia being short-sightedness, okay, the person has no difficulty seeing near object, but the person has difficulty seeing far object. So what we will do is, okay, we will consider the problem that he has. So let us consider his problem where he cannot see far. Okay, so the problem in myopia is that the person cannot see far. Okay, so far objects he cannot see. Okay, so we will consider the far vision of a healthy person. So for a normal eye, the far point of a healthy eye is infinity. So for myopia, the U will be considered for a normal healthy eye. Okay, so U for myopia will be infinity. Now why are we taking infinity? Okay, we are taking infinity because we are considering the far point of a normal healthy eye. Remember, we are doing for myopia. Myopia is short-sightedness, can see very well short objects. Okay, 2 centimeter, 2 centimeters too less, sorry, say 25 centimeter, no problem seeing near, but has difficulty seeing far object, so cannot see. Okay, cannot see far. So we will consider the far vision of a normal healthy eye. Okay, a normal healthy eye has no problem seeing far object. What is the far point of a normal healthy eye? Infinity. So we will be taking U value as infinity. Okay, because we are considering the far point of a normal healthy eye. Now let's immediately go to hypermetropia, and what we will be doing. Okay, we will be doing exactly what we have done for myopia. Let us first understand what is hypermetropia. Hypermetropia is a condition of the eye whereby the person has no difficulty seeing far object but has difficulty seeing nearby object. So here the person has no difficulty seeing far object, but the person has problem seeing near object. Is it not? Cannot see near, so has problem seeing near. Okay, so here what we will do, just like in myopia where we considered the far point of a normal healthy eye. Okay, here we will also be considering something, okay, something from a normal person. But what will we be considering here? Here what did we consider? We considered its problem. Okay, we considered the problem. Here also we'll consider the problem. Okay, so we will consider the problem. The problem in hypermetropia is the person cannot see, a hypermetropic person cannot see near object. Okay, here in myopia, okay, the person could not see far object. So what did we do? We considered the far point of a healthy person. Here the problem is the person cannot see near object. So what will we do? We will consider the near point of a normal healthy person. So the near point of a normal healthy person is how much? Yes, 25 centimeter. So this is what you will do. Okay, this is how you find out U for questions on myopia and questions on hypermetropia. Okay, if you ask me, students, this is the most difficult part. Okay, this is the most difficult part. Students have problem, okay, with these two only. Okay, so this is the most difficult part. So I want you all to master this. Okay, if you have not understood, then rewind back again and watch. Okay, this you have to master. If you have mastered this, then it's very easy. Okay, this is, if you ask me, and I'll be honest with you, this is the part where it will be a little bit challenging for you, but this is it. Okay, after this is very easy. Okay, these are very easy. So now that we are done with U, okay, in both the cases, okay, now let's focus on V. Now from where will we get V? Do we have to find V doing something like this? No, class, no. Okay, for V it will be given in the question. So for V we don't have to do anything, it will be provided in the question. So it will be given in the question. Okay, what about this? Here also same, it will be given in the question. So that's it. How easy is it? Okay, all you have to do is sort out your U. Okay, this may not be provided to you in the question. Okay, I don't think it's provided in the questions given in the textbook also. So this, okay, we have to manage this. So once again I'm repeating that how did we consider, how did infinity come here? Okay, we are taking infinity because we are considering the far point of a normal healthy person. The problem in myopia, cannot see far. To consider U, you will consider the far point of a normal healthy person. Hypermetropia, the problem is the person cannot see near object. So how will we consider U? We'll consider the near point of a normal healthy person. Are we clear? Alright, so it's easy, isn't it? Then one more thing you have to do is do not forget to write, okay, negative, minus in all the values. Okay, u both will be negative. Similarly, v also it will be negative. So all the values, okay, for u and v, okay, on questions where you are supposed to find focus, okay, we are supposed to find power, sorry, not focus, where you are supposed to find power for hypermetropia and myopia, do not forget u and v values will all be in negative. Okay, so with this, okay, it will be not difficult finding f. Okay, so remember, okay, some just note, okay, so remember, to find u, what should you do? You first identify the defect. You first identify the defect. What defect is that? Is it myopia or hypermetropia? Is it myopia or hypermetropia? If it is myopia, then u will be infinity minus. If it is hypermetropia, then u will be, it will be minus 25 centimeter. Okay, then second one, this is point number one, let's say point number one. Then second point, okay, v for both will be negative. Okay, this is it, class. This is it. Okay, super easy, it's not at all difficult. Okay, so now what we will do is we will do the numericals which are given in the textbook. So let us proceed with the numericals now. So here I have written the question. So the question reads, okay, this is taken from the exercise question number 6 from the textbook. So the question reads, the far point of a myopic person is 80 cm in front of the eye. What is the nature and power of the lens required to correct the problem? So what are we supposed to find? We are supposed to find power, and also we have to tell the nature. And the nature means we have to identify what type of lens it is. Is it concave or convex? Now, without solving the question also, you can easily tell the nature. Okay, you can easily tell the nature. So remember, it's myopia. So remember the type of lens which is used for correcting myopia. Okay, so keep it in mind. Later on we'll write it. Okay, now let us solve this question together. Now, how do we do this? Now remember what we have just discussed earlier. Okay, this is from myopia. So first, what we will do, myopia, let's write given. Okay, given. Now we know the first thing is it's myopia as not. So you don't need to read the question also. We have already read the question, but without reading the question also, you can be sure that this is what we are going to use. U, okay, U will not be given to you. U, we have to deduce it by ourselves. So remember, okay, U for myopia is infinity, because here we are taking the far point of a normal healthy person. That's how we are supposed to do. All right, then U is considered. Now V should be given to you in the question. So if you read the question, there is only one number given to you, 80 cm. This is your V. See how easy it is. Okay, then we are supposed to find power. To find power, you need focus. So focus we need. Okay, because without focal length we cannot get power. Power formula is P is equal to 1 by F. We need focal length for that. So let's find focus. So now let's use length formula. We have 1 by V minus 1 by U is equal to 1 by F. This is length formula. Put the values 1 by V. Okay, before I forget, V also will be minus, is it not? Minus, both U and V. Okay, in such questions about myopia and hypermetropia, carry negative sign. So minus, so denominator, I'm supposed to write minus 80, but denominator does not carry negative sign. So let's give it to the numerator. So it will be like this. Then minus 1 by, this is minus infinity is equal to 1 by F. Okay, anything with infinity is Okay, 0. So cancel this one, everything, this becomes 0. Okay, this is 0 now. So what is left is minus 80 is equal to 1 by f. Alright, so what will happen? Cross multiplication will take place. So let's continue here. So 1 into f, so 1 into f, let me do long card, and this will be it will be minus 1 into f, and it will be 80 into 1, which will be 80 only. So f is equal to minus f is equal to 80. Is it? Yes, 1 into f and minus 80. So focal length is equal to minus 80 centimeters. Okay, don't forget the unit, it's 80 centimeter. So focal length we have got. Time to find power. So we have, or we know power is equal to, okay, the unit is in centimeter, class. So if the focal length is given to you in centimeter, we have two formulas for power. We have 1 by f, but this is if power is in meters, focal length is in meters, sorry. Then if the focal length happens to be in centimeter, then the formula is this, okay, for centimeters. This is for centimeter. Since focal length is in centimeter, I will be using this formula. So P is equal to 100 by F. So P is equal to 100 divided by 80. Okay, minus 80. Minus 80 because focal length is minus. This minus will go to the numerator. So cancel. You are left with P is equal to minus 10 by 8. So let's divide this. So 8 will divide 10. So 10 ones are, sorry, 8 ones are 8. Then 2, then 0.0, 8 twos are 16, 17, 18, 19, 20, 4 in hand. Only the point there, so 0, 5s are 40, 8 5s are 40. We are done with the division. We are getting the answer to be P is equal to minus 1.20. What am I writing? Minus 1.25. Okay, diopter. Okay, D. So this is the value of P. Power we have found. Okay, minus 1.25 diopter. So we have just found the power. Then the nature is asking the nature. So what will be the nature, class? What type of lens is this? Okay, what type of lens is this? Now power is negative. Okay, power is negative. Which type of lens has negative power? Concave or convex? Yes, it's concave. It's concave lens. So the nature is concave lens. Remember, correction for myopia is concave lens. So you should be getting, okay, negative here because the lens is a concave lens. If it is convex lens, power should be positive. Okay, so this is how it is done. So like I said, it's not difficult. Okay, it's easy. Okay, it's very easy. All right, so now we will do the other question also. So let's solve the other question together again. So question number 7, let us do question number 7 together now. So the question reads, the near point of a hypermetropic eye is 1 meter. What is the power of the lens required to correct this defect? Assume that the near point of normal eye is 25 centimeter. Very easy. So let's do this together. These kind of questions, okay, are very easy. Okay, so I don't want any of you to have any difficulty in solving these questions. So again, just like the previous question, this will be solved, okay, very easily. Now on reading the question, we come to understand that the person is suffering from hypermetropia. Okay, remember, hypermetropia, long-sightedness, can see far but cannot see near. So here we will consider, okay, the near point of a normal eye, which is 25 centimeter. So remember, we will be writing minus 25 centimeter. So now you tell me, was this necessary for you? Was this necessary for you? No, is it not? See, you don't need this information. Okay, the question is helping you, but once you understand the concept, you don't need this help. Okay, someone who doesn't understand this, okay, will need this help. But for you, you don't need this help. So for you though, now though, you don't need this last sentence. For you, this much is enough. Okay, without this additional help. Okay, also you already know that for hypermetropia you will be minus 25, because that is how it goes, isn't it? So that is the advantage of understanding the concept. Okay, so you don't actually need this. Understood? You don't actually need this last sentence. For you, this sentence, okay, even if it is not written also, you are not going to face any difficulty. All right, so that's how easy it is. Okay, so understand the concept. Okay, once you understand the concept, things are very, very easy. Okay, so let's do the question. It's hypermetropia, so let's write given first, and then we will start with what we know, u. Okay, u, hypermetropia, so it will be minus 25 centimeters. Okay, then v, like I told you, will be provided in the question. On reading the question, I find one information, 1 meter. What will this be? This has to be v. Okay, so it will be v, so this is 1 meter. Okay, we need focus because they want us to find power. We are supposed to find power, so p we have to find. Okay, so what is the power? We need to find power. To find power, we need focal length. Okay, so now let us proceed. So we have length formula, which is 1 by v minus 1 by u is equal to 1 by f. Okay, before we proceed, see, the units are not same. This is in meter, this is in centimeter. So let us make the units same. Let us convert centimeter to meter. So if I have to convert this centimeter to meter, it will be division by 100. After all, 1 meter is equal to 100 centimeter, or 100 centimeter makes 1 meter. Okay, so this will be how much? 0.25 meters minus 0.25 meters is the new, okay, u value. Remember this. So let's put this value. So 1 by v value is okay, see, minus, don't forget to put minus. Okay, u and v will always be minus on questions with hypermetropia and myopia. Remember this. So it will be minus 1 meter. So minus denominator will not carry the sign, so I'll write it in the numerator. So it will be 1. Okay, remember this 1 is this value. This minus, I'm giving it to the numerator because denominator does not carry sign. Okay, then minus from the formula, and then 1, u value is minus again. So we have minus here. So let's put it in bracket, 0.25, and then this is 1 by f. Next thing, I will take care of this sign. So this is minus 1 by 1, this is minus and minus plus, this is, okay, let's remove the decimal, 0.25. So after the decimal, 2 numbers, so upside 2 zeros, you will get here 25, and this is 1 by f. Next step, let's take it to this here. Now this side we have to take LCM. So LCM of 25 and 1. If you take the LCM of 25 and 1, you'll be getting 25 as the LCM. Okay, 1 into 25 is 25, so 25 into 1, 25. So minus 25 here, and plus in the middle, sign is same, plus 25 ones are 25, so it will be 100. This will be 1 by f. So minus 25 plus 100. So we are doing subtraction here, plus into minus, minus. So 25 minus 100 minus 25 will give us 75 by 25, 1 by f. Let's try to simplify this. Let's cut it. So 5 5 the 25, 5, or let's cut with 25 now. 25 ones are 25, 25 threes are 75. So 3 by 1 is equal to 1 by f. So what are we doing? Cross multiplication. So let's go for cross multiplication. So are the signs correct? Yes, correct only. So you will be getting 3 into f, and here you will be getting 1. So f value will be 1 by 3. Okay, this is in meters. So focus value is 1 by 3. Just keep it like that. Okay, we are not done. We need power only. So let's proceed to power. So now let's find power. So power we know is 1 by f. Okay, now this is in meter, so I'll be using this formula. Okay, if it was in centimeter, I'll be using 100 by f, but this is in meter, so this is the correct formula. So power is equal to 1 by f, 1 the actual division, and then this one 1 by 3. So how do I arrange this? This will be arranged like this. It will be 1 into 3 by 1. So power is equal to 3, okay, diopters. So power value is 3 diopter. This is the answer. Okay, this is the answer for this question. So what is the power of the lens required to correct this defect? The power of the lens required to correct this defect is 3 diopter. Is it not? Okay, it's easy, na? So it's easy. Okay, class, it's not difficult. It is very, very easy. So this is it, class. This is how you solve numericals. Okay, for numericals in this chapter, which is human eye and the colorful world. Okay, so I hope you understood this. Okay, if you have still doubts, rewind the video and then see again. I'm sure you'll understand. Okay, this is easy. So class 10 numericals are not difficult. If you ask me, I will say class 9 was a big challenge in science, but class 10, everything is easy in class 10. Mathematics also is easy in class 10. Science also is easy in class 10. So it is easy. Okay, just don't give up. Okay, don't give up. Try. Okay, if you don't succeed once, try twice, thrice. Okay, life is all about trying. So do not accept defeat. If others can do it, you can also do it. Maybe you will need a little more extra practice. So be kind to yourself and give that extra hour, that extra practice, and I guarantee you that you will be doing better. Okay, you'll be doing much better than how you were doing before you gave practice time to yourself. So this is my appeal and my request to all of you. Okay, I want you all to do good in life and especially in your studies. So on this note, I'll end this video and I'll see you again in the next video.